Okay, guys, I'm going to talk to you guys about biconditional statements. If you look at the word biconditional, the prefix bi means two, correct? Didn't circle that. Bi means two. So what is a biconditional sentence? It's just two conditionals in one sentence, right? What are the two conditionals? Well, it's one conditional and its converse, okay? So if I have a conditional and a converse, I can change it into a biconditional, right? Traditionally, we like to write our biconditionals in if and only if form, right? It basically will say hypothesis, if and only if, and then conclusion, okay? Right? So let's take a look at what I'm talking about. It says write the converse of the conditional, then write a biconditional statement in if and only if form. Right? So this says, okay, write the converse of the conditional, then write the biconditional statement in if and only if form. If a person takes geometry, then he or she is a student. Okay, well again, to construct the converse, we just switch the hypothesis and the conclusion. So, I think the converse would be if a person is a student, then he or she takes geometry. Okay? Now, in biconditional form, I'm going to take the hypothesis of the first sentence, the conclusion of the second sentence, and I'm going to create a biconditional in if and only if form by just taking those two phrases and linking them with the phrase if and only if. A person takes geometry if and only if. Now, I'm going to show you something cool right here, right now. The abbreviation for if and only if, that phrase is just IFF. If and only if he or she takes geometry. He or she is a student. My bad. Okay. And that's the sentence in biconditional in if and only if form. Let's do it again. If a number is even, then it is divisible by 2. You guys do that in your notes. You have to have that in your notes the next time we meet, okay? Try rewriting the converse of that and then putting this into biconditional if and only if form, okay? All right, let's move along. The next idea, true biconditionals. Here's the rule. A biconditional statement is only true when both the conditional and the converse are true. Okay? Both of those statements have to be true for a true biconditional to be formed. Alright? Now, here's my rule. In geometry, definitions will only be true if a true biconditional can be made, right? In other words, a good definition has to be a true biconditional. In other words, both the conditional and the converse have to be true statements. Let's take a look at a few examples of what I'm talking about. The first part, write each sentence in if-then form, write the converse of the statement, and decide whether each statement is true. If both are true, create a biconditional sentence. Okay? So the first one. Birds are animals that lay eggs. So what's the initial condition that I'm talking about? Animals that are birds. Would you read this would be my hypothesis? What conclusion can I say about them? That they lay eggs. So the first part, the conditional part, is that I have animals that are birds. That's the hypothesis. So if an animal is a bird, then what conclusion can we make? We can say it lays eggs, can't we? Okay. Now, that's the original sentence. I now have to write the converse. Well, the converse would be if an animal lays eggs, then it is a bird. Okay? All right, so that's the statement and the converse. So I've done the first part. Now it says, tell me whether each one is true. The first sentence, if an animal is a bird, then it lays eggs. Is that a true statement? Yeah, I believe that is true, right? Every bird that I know of lays eggs, right? And remember, for a statement to be true, it always has to be true. Okay? Now, the second part, if an animal lays eggs, then it is a bird. Is that true? Well, no, that's false. And again, for a statement to be false, it only takes one case for it to be false, for it to not come true, for it to be false. I just need one counter example. Well, if you think about it, what kind of animal could lay an egg but not be a bird? Well, couldn't a snake be a counter example to this sentence right here? Right? So the first sentence is true, but the converse is false. So do I need to create a biconditional in this last part? No. Right? Okay. You guys, again, try this sentence. West Virginia is a landlocked state. I want you to create an if-then statement, create the converse, decide whether both are true, and if both are true, create a biconditional. We'll discuss that example in class. All right, the last part. I want you to separate each biconditional statement into a conditional and its converse, and then decide whether each statement is a good definition or not. Okay, the first sentence. A shape is a square if and only if it has four sides. Okay? Well, let's see. Again, I know that in a biconditional, the first part of the if and only if is the hypothesis. The second part, after the if and only if, is the conclusion. So if I wanted to make this into a single conditional, my conditional would be if a shape is a square, then it has four sides. Okay? The converse of that sentence would be if a shape has four sides, then it is a square. So that I've separated the biconditional into the two separate conditionals. Now I've got to decide whether both sentences are true. Well, if I'm looking at a square, does that mean does every square have four sides? Yeah, it does, right? So that's a true statement. But does every shape with four sides have to be a square? Well, let's see here. Would you call this a square? If I've got 1, 2, 3, 4, that shape has four sides, but that's not a square, is it? So that's false, right? So, is this a good definition? Well, again, to determine whether something is a good definition, both the conditional and the converse have to be true. Since they're not true, since they're not both true, this is a bad definition. Okay? Okay? All right. The last sentence. Again, let's take a look at this last sentence here. A biconditional is a good definition if and only if the conditional and its converse are true. You guys separate that into a conditional and its converse and decide the truth values of each sentence to determine whether this is a good definition of a biconditional or not. Okay, folks, that's it for this lesson. We'll talk to you later.